Okay, remembering that the whole reason for doing these augmented matrices and row echelon forms was to be able to get a handle on a system of linear equations. So a matrix still represents a system of linear equations, which any system of linear equations may have a unique solution, just one solution that works, or may have no solution at all. Like if you had an equation that was x equals 3 and another one that said x equals 5, they'd be inconsistent. You can't have a solution to both those equations. So if we have a matrix and one row of the matrix ends up being a whole bunch of zeros and a constant, then it's saying that 0 lots of x1 plus 0 lots of x2 plus a whole bunch of zeros has to equal something, which obviously can't be the case. So if you ever reduce a matrix and it comes out to be a whole bunch of zeros in a C in any row, then you end up with knowing that there's no solution. Okay, so this means that the final column has a pivot. This point is a pivot. It's the first non-zero point in its row, and it's in the final column. So it's inconsistent if the final column contains a pivot. Okay, so if you ever reduce a matrix and you end up with a pivot in the final column, then you know that the system of equations that you started off with was inconsistent.